Algebra 2, Unit 3, Lesson 5, Applications of Two-Variable Systems. So now we want to be able to solve word problems by writing systems to model those. We're going to have three main types: mixture problems, motion, which are distance, rate, time problems, and age problems. In a mixture problem, you want to mix two different kinds of materials with different levels of a substance to get a final amount with some final level of that substance. The variables are typically the unknown amounts of the two materials, and then the other one will come from whatever part of the substance you have in X with that amount of substance in Y, which will be a final amount. Typically these will come from percentages, but they don't have to. So in a percentage one, we have some 75% acid, and then we have some 15% acid solutions. We want to mix them together to give something which is only 50% acid. By the way, it's only possible if the one you want is in between the two that you have. You can't mix two things that are less and get a higher percentage than the biggest one, or something smaller than the lowest one. So X is the number of milliliters of the 75% acid, and Y is the number of milliliters of the 50% acid. If we add those 2 milliliters, the 2 milliliters amount, they have to give us the total milliliters that we have. And then we want to know what part is acid. Well, this X isn't all acid, only 75% of it is acid. And this Y isn't all acid, only 15% of that is acid. So this is the amount of acid in those parts. And then that has to be the same as the total amount of acid in our final mixture, which is supposed to be 50% of 72, or 36, as the final amount of acid. Then we can again solve by elimination or substitution. If you wanted to rewrite this and write X equals Y equals and substitute, you can do that. I prefer to solve by elimination, so I multiplied this first equation by 0.75 so that the X variables would match. Then I subtract because they had the same sign, and I left with 0.6Y is equal to 18. Divide both sides by 0.6, you get Y equals 30. Once you get 30 for Y, 42 has to be X from up there. And then you would write your word problem answer. You need 42 milliliters of 75% acid and 30 milliliters of 50% acid. And again, make sure that you're doing all of the parts. You're defining your variables, you're writing your equations, you're solving, and you're writing an answer in words. For motion problems, again, it's easiest to set up a table of rate, time, and distance. But we're going to include now boat and winds, and what happens is if you have a plane traveling with a wind, the wind makes it go faster. If it's flying into the wind makes it go slower. So if R is the rate of the plane and W is the rate of the wind, then if they're flying with the wind, it will go R plus W. If it's flying against the wind, it will go R minus W. The same is true for boats if they're going downstream. Downstream is the way the water is flowing, so the speed of the current will make the boat go faster, so it will be R plus C. If it's going upstream, it's fighting against that current, then the speed of the boat will be R minus C. You need to remember that when you set up problems that have either currents or winds in them. So we have a riverboat sailing at a rate of 18 miles per hour in still water that can go 63 miles down the river in the same time it takes to go 45 miles up the river. How long does either one take, and what is the speed of the current? So the question has the speed of the current, so that must be one unknown. Let C be the speed of our current. It also asks how long does either take. They're taking the same amount of time, that's what we're told, so T will be either one, it's the time taken. Upstream, well, we know the boat itself goes 18 miles an hour on its own, so it's going to be 18 minus the current when it goes upstream because it's going against the current. It's going to take time T, and we're told that it will go 45 miles up the river. Downstream, the speed of the boat will add with the speed of the current. It'll still take the same amount of time, and that it will go 63 miles based on what they said. The two equations are now this times this equals 45, and this times this is equal to 63. When you do this, even though it's multiplied, these two things match, so we can get rid of them by adding those two equations, and we'll end up with 36T is equal to 108. You find T is 3, then you need to put 3 in one of those equations, and it will go in both places, so I put it in the second one. I put a 3 here and a 3 here, solved that equation and got C is 3. So either trip takes 3 hours, and the speed of the current was 3 miles per hour. We know it's miles per hour because that's what the other speeds were given in. For age problems, you do not have to set up this table. It helps to keep track of. It's not the equations you're keeping track of, it's only the variables. So there are going to be different times mentioned in the question. It might be 10 years ago, 3 years from now, 4 years ago. It might be now. Each one of those will have different variables that represent the ages of your two people. If you write those down, then you'll know which ones to use. So here there's 5 years ago. I'm going to want one column with 5 years ago. And then there's 10 years from now. I'm going to want one column for that. The X and the Y are always for now. So we have Jamila and Ahmed. Their ages now, we'll call them X and Y. 5 years ago, Jamila would have been X minus 5 and Ahmed would have been Y minus 5. 10 years from now, we would add 10 to each of these. That's just so we know the variables. Now when we read the question, if it says 5 years ago, I'm going to use these variables as their ages. If it says 10 years from now, I'm going to use these variables as my ages. So the first statement says 5 years ago, meaning I'm only looking at these now. Ahmed, who was Y minus 5, was, meaning equals, 2/3 the age of Jamila. 10 years from now, he was Y plus 10, will be 5/6 as old as her, so he's 5/6 of her age. And now we want to solve either one of those. Again, you can do elimination or substitution. I chose to get rid of the fractions at the bottom first by multiplying both sides by 3 to get this. Here I wanted to get rid of the 6, so I multiplied everything by 6 to get this. And then I noticed that I could multiply this top one by 2 would make this match here. So I multiplied everything by 2. I then subtracted the first one from the second one to get this equation. X was 20. I picked this one to put 20 back into and solve for Y, which was 15. So Jamila is 20 and Ahmed is 15.